At first, the question sounds simple. If the universe is expanding, what is it expanding into? Most people instinctively imagine an edge, a boundary, a kind of cosmic wall with empty space on the other side. And when they're told that there is no edge, that there is nothing beyond the universe, the confusion deepens. How can something expand if there is nowhere to expand into? In everyday life, expansion always means moving into something else. A balloon expands into air, a fire spreads into empty space, a city grows outward into surrounding land. Expansion, as we experience it, requires room. So when cosmology tells us the universe is expanding, but also tells us there is no outside, no surrounding space, no containers holding it all, the idea feels broken, almost contradictory. For many people, this is the moment where cosmology stops making sense. And that reaction is not irrational. It is intuitive. The problem is not that the question is naive. The problem is that human intuition was never built to understand expansion at this scale, because the universe is not expanding the way objects expand. It is not pushing outward into emptiness. It is doing something far stranger, something that sounds meaningless at first, but becomes unavoidable once you understand what space actually is. To see why, we need to strip away a deeply ingrained assumption. The assumption that space is a stage, that space exists first, and objects move around inside it. That assumption feels obvious, but it is wrong. Space is not a container. It is part of the universe itself, and this single idea changes everything. When cosmologists say the universe is expanding, they are not saying galaxies are flying outward into pre-existing emptiness. They are saying that the distance between everything is increasing. Space itself is stretching everywhere at once. There is no center. There is no edge. There is no direction where expansion is happening more than any other. From any galaxy, every other galaxy appears to be moving away, not because that galaxy is special, but because the space between them is growing. This is already difficult to visualize, but the real confusion begins when we ask the next question. If space itself is expanding, what is space expanding into? The unsettling answer is nothing. Not because there is something mysterious beyond the universe, but because beyond may not be a meaningful concept at all. This is where language begins to fail us. We are trying to describe a process that does not fit inside everyday categories. We are asking where in a situation where may not apply. To understand why, consider this. Imagine a two-dimensional surface. No thickness, no up or down, just the flat world. Now imagine that surface expanding. Every point moves away from every other point. From within that surface, there is no edge you can reach, no boundary you can cross, and no direction that leads outside. From the perspective of someone living on that surface, asking, what is it expanding into, would be a trick question. Because expansion is not happening into anything. It is happening as the surface itself. The universe, according to modern cosmology, behaves in a similar way, except not in two dimensions, in three spatial dimensions, plus time. When the universe expands, it is not moving through a larger space. It is redefining distance internally. The amount of space between points increases, and because space is not embedded in anything larger, there is no external reference, no background, no outside. This is not just a philosophical interpretation. It is what the mathematics demands. The equations that describe cosmic expansion do not include an external container. They do not describe motion through space. They describe the evolution of space itself, and this leads to a conclusion that feels deeply counterintuitive. The universe does not expand into anything because there is nothing for it to expand into. Expansion is not a motion. It is a change in scale. That distinction sounds subtle, but it is absolute, and it is the source of the discomfort, because it means the universe is not like anything we have ever interacted with. There is no edge you could approach, no wall you could reach, no outside you could stand in and look back, even in principle. This does not mean the universe is infinite. It might be finite, it might be infinite. Both are still open possibilities. What matters is that even a finite universe does not require an outside. It can be finite and unbounded, complete, without edges. This idea alone feels almost impossible to hold in the mind, and yet it is one of the most stable conclusions in modern cosmology. The discomfort comes from trying to apply everyday logic to a reality that does not obey it. We keep asking where the universe is going, but the universe is not going anywhere. It is changing internally, and that difference matters more than it seems. Because once you accept that there is no into, a deeper realization follows. The universe is not expanding within something, it is expanding as itself, which means the question is not about what lies beyond the universe. It is about whether beyond exists at all. And that question leads us into territory where intuition becomes unreliable, where words become approximation, and where the universe stops behaving like an object and starts behaving like a process. Once you let go of the idea that the universe is expanding into something, a second intuition collapses almost immediately: the idea of a center. In ordinary expansion, there is always a point of origin. A blast starts somewhere. A ripple spreads from a source. A fire grows outward from a spark. So when people imagine the universe expanding, they instinctively picture a cosmic explosion, matter flying outward from a central point into surrounding emptiness. This image is powerful and completely wrong. There is no center of expansion, not now, not in the past, not even at the Big Bang. This is one of the hardest ideas to accept because it contradicts everything explosions usually mean. But cosmic expansion is not an explosion. It is something stranger. To see why, imagine a simple experiment. Picture a grid drawn on a sheet of rubber. Every intersection is a galaxy. Every line is space. Now stretch the rubber evenly in all directions. As it stretches, every intersection moves away from every other intersection. From the perspective of any one point on the grid, all other points appear to be receding, and yet no point is special. There is no marked center. Every point experiences the same expansion. This is not a metaphor chosen for convenience. It is the structural property of expanding space. In an expanding universe, the idea of a central location simply does not exist. Every galaxy sees the same pattern. The farther away another galaxy is, the faster it appears to be moving away. This relationship is not due to motion through space. It is due to the stretching of space between them. And this leads to a deeply unsettling conclusion. From Earth, it looks like we are at the center of the universe. From a galaxy billions of light years away, they look like the center. Both perspectives are equally valid, and neither is privileged. This is not an illusion. It is a consequence of how expansion works, which means the universe has no unique vantage point, no preferred location, no cosmic frame of reference you could point to and say, this is where it all began. Even the Big Bang was not a point in space. It was a moment in time, a moment when all distances were smaller, when space itself was compressed, everywhere, at once. The Big Bang did not happen somewhere. It happened everywhere. This idea alone rewires how expansion must be understood, because if there is no center, then there can be no outward direction. And if there is no outward direction, then there can be no outside. The universe is not expanding into emptiness. It is expanding as a whole, which brings us back to the original question. If nothing lies beyond the universe, what is it expanding into? The uncomfortable answer remains the same. It isn't. But that answer raises a deeper problem. If there is no outside, then what defines the size of the universe? What does it even mean for it to grow? Here, intuition fails again. When we say the universe is growing, we are not saying that it occupies more space. We are saying that space itself is changing. Distances between points increase over time. But there is no fixed ruler outside the universe to measure that change against. There is no background grid. Everything that exists is participating in the expansion, which means expansion is measured internally by comparing distances at different times, not by comparing the universe to something external. This is why cosmology relies so heavily on time. Expansion is not about where the universe is, it is about when. The universe at one moment compared to itself at another. This shift from space to time is subtle but essential. Without it, the question, what is it expanding into, cannot be answered because it is malformed. It assumes an external frame that does not exist. And this is where the discomfort becomes philosophical. Because humans are deeply attached to the idea of containment, we want things to exist in something, a room, a box, a region. But the universe is not a thing inside another thing. It is the totality of physical existence. There is nothing for it to sit inside, nothing to press against, nothing to spill into. This does not mean the universe is special. It means our language is inadequate. We are trying to describe totality using concepts designed for parts. And that mismatch creates confusion. The confusion becomes even sharper when we consider another implication of expansion. Some regions of the universe are moving away from us faster than the speed of light. This sounds impossible, but it is not, because nothing is moving through space faster than light. Space itself is expanding, and relativity places no speed limit on that. This means there are galaxies whose light will never reach us, not because they are hidden behind an edge, but because the space between us and them is growing too fast. They are not beyond the universe. They are beyond our horizon. This distinction matters. The observable universe is not the whole universe. It is only the region from which light has had time to reach us. Beyond that lies more universe, not outside the universe, more of it. And that alone reshapes the original question. When people ask what lies beyond the universe, they are often imagining what lies beyond what we can see. But visibility is not existence. The universe does not end where observation ends. It simply becomes inaccessible, which means the universe could be vastly larger than what we observe, possibly infinite, possibly finite, but unbounded. Both options remain consistent with current data, and neither requires an outside. This is another point where intuition rebels. How can something be finite but have no boundary? The answer is geometry. On the surface of a sphere, you can travel forever without encountering an edge, yet the surface area is finite. The universe could be similar, not curved like a sphere in 3 dimensions, but shaped in a way that allows finiteness without borders. If so, asking what lies beyond the universe is like asking what lies north of the North Pole. The question assumes a direction that does not exist. This does not mean curiosity is wrong. It means the framework is. The universe forces us to abandon the idea that expansion must resemble growth into emptiness. Instead, expansion is a property of relationships, of distances, of metrics. This is difficult to accept because it feels abstract, but abstraction is unavoidable at this scale. The universe does not cater to intuition. It obeys structure, and structure, once understood, removes the need for an outside entirely. The universe expands, but not into anything. It expands by changing what distance means. And once you accept that, the question transforms. It stops being about space. It becomes about reality itself. Because if space is not a container, then it is not passive. It is dynamic. It can stretch. It can curve. It can evolve. Space is not the stage. It is part of the play. And that realization carries consequences far beyond cosmology. Once the universe is understood as something without an outside, a new and far more disturbing implication emerges. Expansion does not merely separate things. It can erase them, not by destroying them, not by tearing them apart, but by placing them forever beyond reach. This idea is difficult to accept because it sounds like science fiction, but it is a direct consequence of how expanding space behaves. As the universe grows, distances between distant regions increase. For nearby galaxies, gravity can counteract this expansion. Clusters remain bound, stars stay together, planets continue orbiting. But on the largest scales, expansion wins. And when it does, something irreversible happens. There exist regions of the universe that are already moving away from us faster than light. Again, not because anything is violating relativity, but because the space between us and those regions is stretching too quickly. Light emitted from those regions today will never reach us. Not tomorrow, not in a billion years, not ever. Those regions are not hidden behind a wall. They are not blocked by matter. They are simply carried away by the expansion of space itself. This creates what cosmologists call a horizon, not a physical boundary, a causal one. Beyond this horizon, events can still happen. Stars can form, galaxies can collide, entire cosmic histories can unfold, but none of it can influence us. and we cannot influence it. The universe, in this sense, is not only expanding, it is fragmenting into isolated regions of causality. Each region becomes its own island of interaction. This does not happen suddenly. There is no moment when the universe snaps apart. Instead, it happens quietly, gradually, unnoticed. At this very moment, there are galaxies whose light is reaching us for the last time. The photons they emitted billions of years ago are arriving now. But the photons they emit tomorrow will never arrive. Those galaxies will fade from view, not because they disappear, but because space itself carries them away. This is one of the most unsettling consequences of cosmic expansion. The universe can lose contact with parts of itself without violence, without edges, without collapse. This challenges another intuition. We tend to think of existence as permanent once established. If something exists, it exists forever. But in an expanding universe, existence is not the same as accessibility. Something can exist and yet be forever unreachable. This means the universe is larger than anything we will ever observe, and it always will be, no matter how advanced technology becomes. No matter how long we wait, no matter how far we look, there will always be regions of reality that are fundamentally beyond our reach, not because we are limited, but because the universe is structured that way. This brings us back to the original question in a new form. If nothing lies beyond the universe, then why does it feel as though things are disappearing into something? Why does expansion feel like loss? The answer is subtle. Expansion does not push things into an outside. It stretches space so much that relationships break, not physical bonds, causal ones. When two regions become causally disconnected, they might as well be in separate universes. Not literally, but functionally. They can no longer exchange information. No signal can bridge the gap. This means the universe is not just expanding, it is redefining what together means. Early in cosmic history, everything was close. Distances were small. The universe was young, dense, and tightly connected. Light could traverse vast regions. Events in one place could influence distant locations. As expansion continued, those connections weakened, distances grew, communication slowed, and eventually some connections broke entirely. This process is ongoing. The universe today is less connected than it was in the past, and it will be even less connected in the future. This has profound implication. It means the universe has a kind of memory loss built into it, not because information is destroyed, but because information becomes inaccessible. Entire regions of cosmic history will become unreachable, not erased, just forever beyond contact. This is one reason cosmologists care so deeply about the early universe. The earlier you look, the more connected the universe was. The more information you can extract, the more complete the picture becomes. But even that has limits, because expansion imposes a horizon not just on the future, but on the past. There is a limit to how far back we can see, not because the universe had a wall, but because light has only had so much time to travel. The observable universe is not a sphere cut out of a larger space. It is a region defined by time. It marks how far light could have traveled since the beginning. Beyond it lies more universe, not empty space, not nothingness, just more of the same reality, unseen, unreachable. This realization reframes the question of expansion again. The universe is not expanding into something else. It is expanding in such a way that parts of itself are lost to one another. The sense of into comes from our experience of separation. We mistake disconnection for externality, but there is no external place where lost galaxies go. They remain within the universe. They simply leave our causal reach. This is why the idea of an outside feels tempting. It gives separation a location, but in cosmology, separation does not require location. It only requires scale, and scale is changing. This leads to one of the most counterintuitive facts about reality. There is no moment when the universe becomes complete, no final shape, no finished size. The universe is not an object that can be measured from the outside. It is a process unfolding internally, and that process does not care about our need for closure. Which brings us to a deeply unsettling thought. If the universe has no outside, And if expansion can permanently isolate regions, then the universe we experience is not the universe. It is a shrinking fraction of it. Over time, fewer and fewer galaxies will remain visible. Eventually, distant clusters will fade. The night sky will grow darker, not because stars die, but because space stretches faster than light can travel. In the far future, observers in galaxies like ours may see only their own local group. Everything else will have slipped beyond the horizon. To them, the universe will appear smaller, not because it is, but because connectivity has collapsed. This future isolation does not require catastrophe. It is a natural outcome of expansion, and it reinforces the core idea. The universe is not expanding into emptiness. It is expanding in a way that changes what can be known. This turns the original question inward. Instead of asking what lies beyond the universe, we are forced to ask, what lies beyond what we can ever observe? And the answer is unsettling in a different way, probably everything else. At this point, the question is transformed. We no longer ask what the universe is expanding into because we expect an answer. We ask it because something in us refuses to let go of the idea that there must be an outside, and that refusal is revealing. It exposes a tension between how reality behaves and how the human mind demands it behave. We are creatures of boundaries. Every experience we have ever had occurs inside something: a room, a city, a planet, a sky. Even when we imagine infinity, we imagine it as endless extension, space continuing forever in some direction. But the universe does not cooperate with this instinct. It offers no edge, no border, no surrounding emptiness. And that absence feels wrong. Not because it is logically inconsistent, but because it violates expectation. The question, what is it expanding into, keeps resurfacing because it is not really a scientific question. It is a psychological one. It reflects a need for containment, a desire for reality to have an outside we can point to, something familiar, something graspable. But the universe resists that comfort. It forces us to accept that some concepts simply do not apply at the largest scale. Outside may be one of them. This does not mean the question is meaningless. It means it is misdirected, like asking what time was doing before time existed, or what direction lies beyond all directions. The universe does not owe us intuitive answers. It only owes us consistency. And in this case, consistency demands something radical. That space is not embedded in anything larger. That expansion is not motion through emptiness. That the universe is not a thing inside a container. It is the container. And even that word fails, because a container implies separation. And separation is exactly what does not exist at the largest scale. There is no place to stand outside the universe and watch it grow, not even in principle. This is not a limitation of technology. It is a limitation of meaning. The universe includes all locations, so there can be no location beyond it. This is why cosmology is so deeply unsettling, not because it reveals strange objects or violent events, but because it dismantles assumptions we did not know we were making. We assume that existence requires a backdrop. We assume that growth requires space. We assume that every inside implies an outside. The universe violates all three, and it does so quietly, without contradiction, without paradox. The equations describing expansion are internally consistent. They do not struggle with the lack of an outside. Only we do. This is why metaphors are often used to explain cosmic expansion. Balloons, raisins in dough, stretching surfaces. But metaphors are not explanations. They are scaffolding. They help us climb toward understanding, but they must eventually be discarded, because every metaphor breaks at some point. The balloon expands into air. The dough sits in a kitchen. The surface exists in higher dimension. The universe does none of these things. There is no air, no kitchen, no higher space we can meaningfully point to. The universe expands without reference, without context, without comparison. And this forces us into an unfamiliar position. We must accept a process that cannot be visualized externally, only internally. This is why cosmology relies so heavily on mathematics. Not because math is abstract, but because language fails. Mathematics can describe relationships without requiring imagery. It can define expansion without an outside. It can encode change without motion. And when those equations are followed to their conclusions, they consistently tell the same story. The universe expands, but not into anything. It expands by redefining distance, by stretching the fabric of space itself. And once that is accepted, something strange happens. The question that once felt urgent begins to dissolve, not because it has been answered, but because it no longer applies. We stop asking where the universe is going. We start asking how it changes. We stop looking for edges. We start examining structure. We stop demanding an outside. We start accepting totality. This shift is subtle, but it is profound, because it changes how we relate to reality. Instead of seeing the universe as an object in space, we see it as a system unfolding in time. Instead of imagining ourselves inside something larger, we realize there is nothing larger to be inside. We are not contained by the universe. We are expressions of it, and that realization carries an unsettling calm. There is nowhere to fall out, nowhere to escape to, nowhere beyond reality. Everything that exists is already included. This does not make the universe feel smaller. It makes it feel complete, not finished, not static, but whole, which raises one final discomfort. If the universe has no outside, no edge, no container, then our instinct to look beyond it will never be satisfied. There will always be a sense that something is missing, some unanswered where, some unresolved into. But that discomfort is not a flaw in understanding. It is a signal that understanding has reached its boundary, the boundary between intuition and reality. And that boundary is where cosmology always lives. The universe is not obligated to fit inside human categories. It only needs to be internally consistent. And in this case, it is. Expansion without an outside is not a paradox. It is a reminder that the deepest features of reality do not resemble everyday experience, that space is not passive, that scale changes meaning, and that some questions feel profound precisely because they are framed incorrectly. The universe does not expand into nothing. It expands as itself, and that distinction, once accepted, reshapes everything that follows. Because once you stop looking for an outside, you begin to ask better questions. Questions not about where the universe is going, but about why it behaves the way it does. And those questions take us deeper, not outward. Once the idea of an outside is abandoned, a deeper confusion takes its place. If the universe is not expanding into anything, then what does expansion actually mean in physical terms? This is where many explanations quietly fail. They reassure intuition without explaining reality. They say space stretches, but never clarify how stretching can happen without tearing, without edges, and without a background. To understand this, we have to confront a truth that feels abstract but is unavoidable. Space is not a thing, it is a relationship. In physics, distance does not exist independently of what it connects. There is no universal ruler embedded in reality. There is no grid behind the universe marking position. Distance is defined by how objects relate to one another. And when cosmologists say the universe is expanding, they mean those relationships are changing. Two galaxies that are not gravitationally bound drift farther apart over time, not because they are accelerating through space, but because the definition of distance between them evolves. This is encoded mathematically in the geometry of space-time itself. The universe is described not as objects moving through a static arena, but as a dynamic geometry in which the arena itself evolves. This idea originates in general relativity. In Einstein's theory, gravity is not a force pulling objects together across empty space. It is the curvature of space-time. Matter tells space how to curve. Curved space tells matter how to move. This relationship means space is not passive. It can bend, it can ripple, and crucially, it can expand. Cosmic expansion is not an explosion. It is a solution to Einstein's equation. When those equations are applied to a universe filled with matter and energy, they naturally produce a dynamic spacetime, one that either contracts or expands. A static universe is unstable. It cannot remain frozen. This was one of the earliest shocks of modern cosmology. The universe, according to the mathematics, must change. And once expansion begins, it does not require an external cause to continue. Space expands because the equations describing it permit and often demand it. This is why asking what space expands into is misleading. Space is not an object undergoing motion. It is the structure defining motion itself. It does not move, it evolves. And evolution does not require a destination. It requires rules. Those rules are encoded in the metric of spacetime. The metric is what defines distance, time intervals, and angles. When the universe expands, the metric changes. Distances between points increase. But there is no background against which this increase is measured. Everything that exists is measured using the same evolving metric, which means expansion is absolute internally and meaningless externally. This is where the concept of scale becomes essential. In an expanding universe, scale is time-dependent. A meter today is not the same cosmic fraction as a meter billions of years ago. Local rulers remain stable because forces like electromagnetism and gravity hold atoms together. But between distant, unbound regions, scale changes. Space grows where nothing resists it. This selective expansion explains why we do not feel the universe expanding. Our bodies are bound. The Earth is bound. The solar system is bound. The Milky Way is bound. Expansion happens in the gaps between galaxy clusters, between large-scale structures, in regions where gravity is too weak to counteract it. This makes expansion invisible in daily life, but its effects accumulate over cosmic distances. This leads to another deeply counterintuitive consequence. There is no maximum size the universe is approaching, no final shape, no moment when expansion completes. As long as the conditions driving expansion persist, space will continue to grow, and current observations suggest that expansion is not slowing down. It is accelerating. This acceleration is attributed to dark energy, a form of energy inherent to space itself. Dark energy does not clump. It does not dilute as space expands. Its density remains nearly constant, which means that as space grows, the total amount of dark energy increases. Not because it is created from nothing, but because it is a property of space. More space means more dark energy. More dark energy means stronger expansion. This feedback loop drives acceleration, and acceleration changes the structure of horizons. More regions become unreachable. More connections are lost, not because the universe ends, but because its internal geometry evolves. Again, there is no external comparison, no container filling up, no edge approaching something else, only relationship stretching. This internal nature of expansion explains why the universe can be both finite and unbounded. If space curves back on itself, it can have a total volume without edges, like the surface of a sphere, except in higher dimensions. Such a universe can expand forever without ever encountering an outside, because there is no outside to encounter. This is not speculation. It is a direct consequence of geometry, and geometry does not require embedding. A shape does not need to exist inside something else to be well defined. This is another place where intuition fails. We are accustomed to shapes existing in space, but space itself does not need a higher space to exist in. It only needs internal consistency. The universe satisfies that requirement, which brings us back to the emotional core of the question. Why does expansion feel like motion into emptiness? Because emptiness is how we imagine absence, and absence is how we imagine what lies beyond boundary. But the universe has no boundary, so absence cannot be located. It cannot be pointed to. It cannot be entered. The only absence that exists in cosmology is causal absence, regions that can no longer affect us, not regions that lie beyond existence. This reframing removes the need for an outside entirely. The universe expands not by invading emptiness, but by changing what emptiness means. And that meaning is defined internally. This is the key insight that separates intuition from reality. Space is not the background of the universe. It is part of the universe. And when it expands, it does not require a destination, only equation. The moment faster than light expansion enters the conversation, intuition collapses completely. Relativity tells us that nothing can travel faster than light. This rule feels absolute. It has been tested repeatedly. It underpins modern physics. It shapes how we think about causality. So when cosmologists say that distant galaxies are receding from us faster than the speed of light, the statement sounds like a violation. It is not. But understanding why requires another shift in perspective. Relativity limits how fast objects can move through space. It says nothing about how fast space itself can change. This distinction is subtle but essential. In an expanding universe, galaxies are not racing through space at extreme speeds. They are, for the most part, relatively still. What is changing is the distance between them, and distance is defined by the geometry of space. When that geometry evolves, distances can increase at any rate without violating relativity. This is not a loophole. It is built into the theory from the beginning. Einstein's equations describe how space-time evolves under the influence of energy and matter. They allow the metric, the rulebook that defines distance, to change over time. When the metric changes, distances change. No object needs to move locally at all. This is why faster-than-light recession is allowed, and it is why expansion does not conflict with relativity. But this explanation, while correct, feels unsatisfying because it replaces one mystery with another. If distances can increase faster than light can traverse them, then some parts of the universe must be permanently inaccessible. And that is exactly what happens. There exists a cosmic horizon beyond which events cannot influence us. This horizon is not static, it evolves. As expansion accelerates, the horizon shrinks in comoving terms. More regions slip beyond it. This does not mean they disappear. It means the future light they emit will never arrive. This creates a peculiar situation. At the moment we observe a distant galaxy, we are seeing it as it was billions of years ago. But that same galaxy today may already be beyond our causal reach. Its present state is unknowable to us, and always will be. This means the universe we observe is not the universe as it is. It is the universe as it was, filtered through time, filtered through expansion, filtered through horizons. This is not new. Astronomy has always looked into the past. But cosmic acceleration makes the past permanent. It freezes certain moments into our observational window and erases others forever. This erasure is not symmetric. We do not lose information evenly. Some regions become unreachable sooner than others. Some histories are preserved, others vanish. This asymmetry gives expansion a direction, not spatially, temporally. The universe has a built-in arrow that determines what can be known, and that arrow is defined by expansion. This leads to a deeper discomfort. If faster-than-light expansion can isolate regions forever, then the universe is not a single, continuously interacting system. It is a collection of regions whose interactions diminish over time. The universe becomes more fragmented, not in structure, but in causality. This fragmentation is subtle. It does not tear matter apart. It does not disrupt local physics, but it redraws the boundaries of influence. And those boundaries are invisible. No signal announces them. No wall marks their position. A region can cross beyond our horizon without any local event. One day it is observable, another day it is not. This is deeply unintuitive. We expect boundaries to be physical. We expect separation to be violent. But cosmic separation is quiet. It happens through stretching, through scale, through the slow evolution of geometry, which means that the universe can hide things from us without hiding them anywhere. There is no place they go. They remain exactly where they are. What changes is the relationship between us and them. And this returns us to the original question once again. If the universe is expanding, but nothing lies beyond it, why does it feel as though things are moving away into something? Because our brains interpret increasing distance as movement, and movement implies destination. But in cosmology, distance can increase without motion and without destination. The universe is not evacuating its contents. It is redefining proximity. This redefinition is governed by the expansion rate, which today is dominated by dark energy. Dark energy does not behave like matter. Matter dilutes as space expands. Dark energy does not. Its density remains nearly constant, which means that as the universe grows, dark energy becomes more influential. This dominance accelerates expansion, and accelerated expansion sharpens horizons. more regions become causally disconnected. This is not speculation. It is a prediction, and all current observations support it. The universe will not tear itself apart locally, but on the largest scales, it will become increasingly isolated. Galaxies outside our local group will eventually disappear from view, not because they vanish, but because the space between us expands faster than light can cross it. In the distant future, observers will see a much smaller universe. They will not detect expansion easily. They may not detect the cosmic microwave background. They may conclude incorrectly that the universe is static and small. The evidence of expansion will have slipped beyond their horizon. This is a sobering thought. It means that knowledge itself is time-dependent. What can be known depends on when you exist. The universe reveals different truths at different epochs. We are fortunate or unfortunate to exist at a time when expansion is still observable. This again reframes the question. We are not asking what the universe is expanding into. We are asking how expansion reshapes what can ever be known, and the answer is unsettling. Expansion does not just change distances. It changes epistemology. It determines what information is accessible and what is lost forever. This makes the universe feel less like a place and more like a process that reveals itself selectively, gradually, irreversibly. And in such a process, the idea of an outside is irrelevant. What matters is connection, causality, reach, and expansion quietly erodes all three. The universe does not need an edge to hide things from us. It only needs scale, and scale is changing. Once faster-than-light expansion is understood as a feature of geometry rather than motion, a deeper question becomes unavoidable. Why did expansion begin in the first place? Why does space change at all? Because nothing in everyday experience suggests that space should be dynamic. Rooms do not grow overnight. Distances between cities do not quietly increase. Space, to us, feels inert. But in cosmology, stillness is the exception. Change is the default. When Einstein first applied his equations to the universe as a whole, he discovered something unsettling. A universe filled with matter could not remain static. Gravity would cause it to contract, or, if conditions were right, it would expand. A perfectly balanced, unmoving universe was mathematically unstable. Any tiny disturbance would tip it. This realization contradicted intuition at the time. The prevailing belief was that the universe was eternal and unchanging on the largest scales. To preserve that belief, Einstein introduced an additional term into his equations, a counteracting effect designed to hold the universe still. Later, when expansion was observed, he famously abandoned this adjustment. But the deeper lesson remained. Space, governed by general relativity, does not want to remain fixed. It evolves. Expansion is not something imposed on the universe from the outside. It is something the equations naturally allow and often require. This means the universe does not need a reason to expand in the everyday sense. It does not need a push. It needs only initial conditions. Once expansion begins, it follows from the structure of space-time itself. This leads to a subtle but important point. The Big Bang was not an explosion that launched expansion. It was the initial state of an already expanding universe. Expansion did not happen at the Big Bang. Expansion is what the Big Bang was. A moment when space itself was extremely compressed, hot, dense, and then began to evolve. This reframing eliminates another intuitive mistake. We often imagine the Big Bang as a point in space that exploded outward, but there was no space for it to explode into. Space was part of the event. Everywhere that exists today was present then, but at vastly smaller scales. There was no empty surroundings, no waiting void. Only the universe, already complete in extent, but radically different in scale. This brings us back to inevitability. If expansion follows naturally from the equations, then a static universe is not the norm. It is a fragile special case. This means that asking why the universe expands is like asking why unstable systems change. They do, because they cannot remain balanced indefinitely. But this explanation opens a new line of inquiry. If expansion is natural, is acceleration natural too? Or is something extra required? This is where dark energy re-enters the story. Dark energy behaves unlike anything else we know. Matter attracts. Radiation dilutes. Dark energy persists. Its effect becomes stronger as the universe grows. This creates a late-time acceleration. But dark energy was not always dominant. Early in the universe, matter and radiation controlled expansion. The expansion rate slowed. Structures formed. Galaxies assembled. Only later did dark energy take over. This transition raises an important question. Is dark energy a fundamental feature of space, or is it a temporary phenomenon? If it is fundamental, expansion will continue forever. If it is temporary, the universe's fate could change. Expansion could slow, stop, or even reverse. This uncertainty highlights a key fact. Cosmology does not yet know why expansion behaves the way it does. The equations describe how it evolves. They do not explain why the constants have the values they do. They do not explain why dark energy exists at all. They do not explain why expansion began in the first place. These why questions sit at the edge of physics. They touch on deeper theories that remain incomplete: quantum gravity, vacuum energy, the nature of space-time itself. This is where the question of what is the universe expanding into becomes a proxy. It stands in for a deeper discomfort, not about space, but about origin. We want expansion to have a cause we can picture, a trigger, an external referent, but the universe offers none. It presents expansion as a consequence of its own structure, self-contained, self-consistent, and fundamentally internal. This makes the universe feel closed in an unsettling way. Not physically closed. Conceptually closed, there is no external vantage point, no higher frame, no larger arena. The universe is not a subsystem. It is the system. This realization collides with another assumption, that beginnings require a before. But if time itself is part of the universe, then before the Big Bang may not be meaningful. Expansion begins with time, not within it. This does not mean nothing preceded the universe. It means that preceded may not apply. The question may be malformed, just as asking what lies north of the North Pole is malformed. This does not satisfy curiosity. It redirects it. Instead of asking what came before, cosmologists ask how early conditions behave. Instead of asking what space expands into, they ask how space-time evolves. These are harder questions, but they are better posed. They accept the universe on its own terms, and those terms do not include an outside. This is perhaps the most difficult adjustment of all, accepting that the universe does not sit within anything else, that it does not require context beyond itself, that it is, in a sense, complete, not finished, not static, but self-contained. This does not remove mystery, it concentrates it. All explanations must be internal. All causes must arise from within. All structure must emerge without reference to something beyond. This is why cosmology feels so different from other sciences. In chemistry, you can isolate systems. In biology, you can study environments. In physics, you can build experiments. In cosmology, you cannot step outside the system you are studying. You are part of it, which means some questions will always feel unanswered, not because answers are missing, but because the questions assume perspectives that do not exist. The universe expands because its geometry allows it. It continues because nothing halts it, and it does not expand into anything because there is nothing else for it to expand into. This is not an admission of ignorance. It is a statement of structure. The universe does not need an outside to grow. It needs only time, and time, like space, is part of the same unfolding. At this point, a pattern has emerged. Every attempt to locate an outside fails. Every attempt to assign expansion a destination dissolves. Every effort to visualize the universe as something moving through something else collapses under scrutiny, not because the universe is hiding an answer, but because the question itself assumes a framework that does not exist. The universe expands, and it does so without reference. This is not a temporary gap in understanding. It is a structural feature of reality as described by modern cosmology. And this is where the deepest implication begins to surface. The universe may continue expanding forever, and without ever providing the kind of explanation our intuition demands. because there may be no additional layer beneath the one we already see, no external arena, no surrounding emptiness, no higher space in which the universe is embedded. Expansion may be a complete description, not incomplete, complete. This is difficult to accept because it runs counter to a powerful human instinct. When something changes, we expect it to be changing relative to something else. Speed requires distance. Growth requires room. Movement requires background. But cosmic expansion requires none of these. It is not motion. It is not growth into space. It is the evolution of the metric that defines distance itself. And once you accept this, something subtle happens. The question, what is it expanding into, loses its urgency. Not because it has been answered, but because it no longer applies. This is not how most questions in science end. Usually a question leads to a deeper answer. Here, the question dissolves. And that dissolution feels unsatisfying. It feels like a failure, but it is not. It is a sign that the question belongs to an earlier stage of understanding, a stage where space was assumed to be static, a stage where containment was assumed to be universal. The universe does not conform to those assumptions, and it does not apologize for it. This realization forces a reevaluation of how we interpret cosmological explanations. We often imagine science as a process that fills gaps, but sometimes progress comes from removing assumptions, from realizing that a gap was never real, that it was created by a misleading frame. The outside of the universe is such a frame. It feels necessary, it feels obvious, but it is not required by the theory, and it is not supported by observation. This does not mean the universe is simple. On the contrary, it means complexity is internal. All structure, all change, all evolution occurs without reference to anything beyond, which raises a quiet but profound possibility. The universe may be the maximal context. There may be no higher level of description waiting beyond cosmology, no external system, no background reality. This does not rule out speculative ideas like multiverses or higher dimensions, but even those ideas, when properly framed, do not provide an outside in the intuitive sense. They describe additional structure, not a container. Even a multiverse would not be a space the universe expands into. It would be a larger structure of which our universe is a part, and that structure too would raise the same question. What does it exist in? At some point, the chain must end. Cosmology suggests that it may already have. The universe may not be embedded. It may be fundamental. This is not a claim of finality. It is a recognition of scope. The laws we use describe the universe from the inside because there is no outside to describe it from. This internal perspective is not a limitation of science. It is an honest reflection of reality's structure, and it explains why the expansion question feels perpetually unresolved. Because we are asking for an external explanation of an internal process, and no such explanation exists. The universe does not expand into something else. It expands as a manifestation of its own geometry, and that geometry evolves according to rules that do not require reference to anything beyond. This means the universe could expand forever, not toward a destination, not toward an edge, but simply by continuing to evolve, scale increasing, distances stretching, horizons sharpening, connectivity fading, all without crossing a boundary, all without encountering resistance, all without ever answering the question of into. This future is not dramatic. There is no final moment where expansion reveals its purpose, no point where the universe breaks through into something larger, no cosmic reveal, just continued unfolding, quiet, relentless. This is perhaps the most unsettling conclusion of all, that the universe does not owe us a satisfying image, that it does not end with a conceptual resolution, that some questions are not answered with facts, but with reframing. The universe expands, not into anything, but away from earlier versions of itself, and that may be the only sense in which into applies. Expansion is not spatial, it is historical. The universe moves from one state to another, from denser to emptier, from connected to isolated, from accessible to unreachable. This is a change in condition, not location. and it suggests that the deepest description of reality is not geometric, but relational. What matters is not where things are, but how they relate, and those relationships evolve. Which means the universe is not a thing growing in space. It is a network of relationships evolving in time. This view strips away the need for an outside completely. There is nothing missing, nothing left out, nothing beyond, only internal change. This does not make the universe smaller. It makes it harder to grasp, and perhaps that is the point. The universe is not obligated to match the scale of human intuition. It existed long before us. It will continue long after, and its deepest behaviors may remain permanently resistant to everyday imagery. Expansion without an outside is one such behavior. It does not signal a failure of understanding. It signals the limits of metaphor, and recognizing those limits is a form of understanding in itself. With this realization, Section 2 comes to an end. We have seen how expansion works, why faster-than-light recession is allowed, why space does not need an external arena, and why the universe may expand forever without ever revealing an outside. What remains is the final step. If the universe expands this way, what does that mean for its fate, for meaning, for our place within it? Those questions lead us into the final section. Once the mechanics of expansion are understood, attention inevitably shifts toward consequence, not how expansion works, but what it leads to. Because an expanding universe is not neutral, it changes the future in irreversible ways. Every increase in distance alters what can interact, what can influence, and what can remain connected. Expansion is not just a background process. It is destiny written into geometry. The most immediate consequence is isolation. As space expands, gravitationally bound systems remain intact, but everything else drifts apart. Galaxy clusters separate, large-scale structures thin, connections that once existed weaken and eventually break. This does not happen suddenly. There is no cosmic fracture. Instead, the universe becomes more diluted over time. Matter spreads, energy thins, events grow rarer. The universe does not end, it quiets. This future is often described in terms of heat death, but that phrase hides the true nature of what is happening. Heat death is not an explosion, collapse, or extinction. It is the gradual loss of usable energy. The universe approaches a state where differences fade, where temperature gradients vanish, where processes that depend on imbalance can no longer operate. Expansion accelerates this outcome. As space grows, matter becomes more sparsely distributed. Interactions become less frequent. Stars form more slowly. Eventually, they stop forming altogether. Galaxies exhaust their gas. Existing stars burn out. Black holes evaporate. What remains is a vast, cold, dilute universe, not empty, but functionally inert. This future is not speculative fantasy. It is the logical extension of current observations. Dark energy continues to dominate. Expansion continues to accelerate. The universe moves steadily toward a state of maximum entropy. But entropy, in this context, does not mean chaos. It means uniformity, and uniformity is silent. This raises a difficult question. If the universe is expanding forever, and if expansion leads to isolation and stillness, what does that say about meaning, about structure, about significance? These questions are not scientific in the narrow sense, but they arise inevitably from scientific conclusions. An eternal expansion implies that the universe is not moving toward a dramatic end. There is no final collapse, no reversal, no cosmic punctuation, just continuation. This continuity challenges narrative expectations. We expect stories to end. We expect arcs. We expect closure. The universe offers none. It simply keeps changing. And in doing so, it gradually removes the conditions that make change interesting. This does not mean the universe becomes meaningless, but it forces us to rethink where meaning comes from. Meaning, in a physical sense, arises from difference, from contrast, from interaction. Expansion erodes all three. The future universe will contain matter but little interaction, energy but little structure, time but few events. This is not because the universe fails. It is because it succeeds at expanding, which brings us back to the original question from a different angle. If nothing lies beyond the universe, and if the universe expands forever, then the universe is not moving towards something. It is moving away from itself, away from density, away from connection, away from complexity. Expansion becomes a kind of forgetting, not of information, which is conserved, but of relevance. Things still exist. They simply no longer matter to one another. This is a deeply unsettling idea. It suggests that the universe does not accumulate meaning over time. It dissipates it. The early universe was dense, connected, energetic. The future universe will be sparse, isolated, quiet. Complexity emerges early, then slowly fades. This inversion is counterintuitive. We expect complexity to build, but cosmology suggests it peaks and then declines. This makes the present moment unusual. We exist during a narrow window when stars shine, galaxies interact, and energy gradients exist. This window is not eternal. It is temporary, and expansion defines its limits. Which leads to another implication. The universe's most interesting phase may already be behind it, not because it is ending, but because the conditions that allow complexity are fleeting. This does not diminish the present. It emphasizes it. It places us within a specific era of cosmic history, an era defined by expansion that is slow enough to allow structure, but fast enough to prevent collapse. A balance. And balance, in cosmology, is rare. This realization gives expansion a new role. It is not just a process, it is a filter. It determines when and where complexity can exist. Too little expansion, and the universe collapses. Too much, and it thins too quickly. The current rate sits in between, allowing galaxies, stars, planets, and observers. This raises uncomfortable questions. Is this balance coincidental, temporary, or necessary? Physics does not yet answer this, but expansion makes the question unavoidable. If the universe had expanded differently, structure might never have formed, or might have collapsed quickly. Our existence depends on a specific expansion history. This does not imply design, it implies sensitivity. And sensitivity suggests that expansion is not a background detail. It is a central feature shaping cosmic history, which brings us back to the feeling that something is missing. When we ask what the universe is expanding into, we are not just asking about space. We are asking about direction, about purpose, about destination. Expansion denies all three. There is no direction, no purpose built into the process, no destination waiting, just evolution according to internal rules. And this absence is difficult to accept, not because it is bleak, but because it removes narrative structure. The universe does not appear to be going anywhere in particular. It is not building towards something. It is changing because change is allowed. This does not render the universe meaningless. It renders it indifferent to meaning. Meaning arises locally, temporarily, within pockets of structure, within windows of time. Expansion ensures those windows open and close. And once closed, they do not reopen. This makes the universe feel fragile, but fragility is relative. The universe itself is robust. It persists. What is fragile are the conditions that allow complexity, and expansion steadily erodes those conditions, which means that expansion is not just a physical process. It is a limit, a boundary in time, beyond which certain phenomena cannot occur. Life, structure, observation. These are not guaranteed forever. They are permitted for a time. Expansion defines that time, and in doing so, it frames the entire cosmic story, not as a journey toward an outside, but as a slow, internal drift toward stillness. This is not a conclusion. It is a trajectory. And understanding that trajectory forces us to confront the universe not as a place, but as a history. Despite how often cosmic expansion is described as inevitable, certainty is not as complete as it appears. The equations suggest a trajectory. They do not guarantee a conclusion. Cosmology deals in probabilities constrained by observation, not absolute destinies. And when it comes to the far future of the universe, small uncertainties become decisive. Everything hinges on the nature of dark energy. At present, dark energy appears remarkably stable. Its density does not change as space expands. This constancy drives acceleration. And if it remains unchanged forever, the universe's fate is largely sealed. Expansion will continue. Isolation will deepen. Structure will fade. But this conclusion rests on an assumption that dark energy is truly constant, that it does not evolve, that it is not a temporary manifestation of a deeper process. And this assumption, while supported by current data, is not proven. Dark energy is measured indirectly. We infer its existence from how expansion behaves. We do not observe it directly. We do not know its origin. We do not know its composition. We do not know whether it will remain the same indefinitely. This uncertainty leaves room for radically different futures. If dark energy weakens over time, expansion could slow. If it fades entirely, gravity could regain dominance. The universe could stabilize or even begin to contract. In such a scenario, isolation would not be permanent. Horizons could shift. Regions now unreachable might re-enter causal contact. The universe would not be expanding into nothing. It would be turning inward. This possibility is often dismissed as speculative, but it remains consistent with current observations. We simply do not have enough data to rule it out. Another possibility is even more extreme. If dark energy strengthens over time, expansion could accelerate catastrophically. Distances would increase at an ever-growing rate. Bound structures could eventually be torn apart. First galaxy clusters, then galaxies, then solar systems, then atoms themselves. This scenario is known as the Big Rip. It represents a universe where expansion overwhelms every force, even those that bind matter at the smallest scales. In such a universe, the question of what lies beyond becomes irrelevant. There would be no coherent structures left to ask it. But again, this outcome depends on assumptions. We do not know whether dark energy behaves this way. The data does not currently support it, but it cannot yet exclude it entirely. Between these extremes lies a range of possibilities. Expansion could asymptotically approach a steady rate. It could oscillate. It could transition through phases we do not yet understand. Cosmic history may not be monotonic. It may contain surprises. This uncertainty reveals something important. The universe's fate is not fully determined by what we know now, which means that expansion is not just a settled fact. It is an ongoing measurement. Every new observation refines the trajectory. This makes the question of expansion feel less final, less absolute. The universe may not be locked into a single future. It may be exploring possibilities. This idea resonates with a broader theme in cosmology, that the universe is not a static solution. It is a dynamic process. Its behavior emerges from interactions between geometry, energy, and matter, and small changes can have enormous long-term effects. This sensitivity is unsettling because it means that cosmic destiny is fragile, dependent on parameters we barely understand, which returns us to the psychological weight of expansion. We want the universe to be simple, to follow a clear arc, to move toward a comprehensible end. But cosmology offers something messier, a future contingent on unknown physics, on properties of reality we have not yet measured. This uncertainty undermines the comfort of inevitability. It reminds us that even on the largest scales, the universe is not fully predictable, and that unpredictability matters, because it means that asking what the universe is expanding into is not the deepest question. The deeper question is whether expansion itself is permanent, whether it is a phase, a condition, or a transient feature of cosmic history. If expansion is temporary, then the absence of an outside becomes less troubling, because the universe's behavior changes. But if expansion is permanent, then the lack of an outside becomes fundamental, a defining feature of reality. This distinction shapes how we think about totality. If expansion ends or reverses, the universe may enter a new regime, a regime where distances shrink, where horizons recede, where connectivity returns. In such a universe, the idea of an outside remains meaningless, but the sense of loss fades. If expansion never ends, isolation becomes permanent, not because the universe ends, but because it never reconnects. This uncertainty leaves cosmology in a delicate position. We can describe what expansion does. We can model how it behaves under certain assumptions, but we cannot yet say what it ultimately leads to. And that inability is not a weakness. It is an honest boundary. The universe has not revealed all its parameters, and until it does, its fate remains open. This openness reframes expansion yet again. It is not a march toward emptiness. It is a conditional process, one whose outcome depends on physics we have not yet uncovered. This is why the question of what lies beyond persists. It is not really about space. It is about completeness. We want to know whether the universe is finished revealing itself, whether its structure is fixed, or whether it still holds surprises that could alter everything. Expansion may be one such surprise. It began, it continues, but it may not be final. This uncertainty does not restore the idea of an outside. It reinforces its absence. Because regardless of how expansion evolves, it does so internally. There is no external trigger, no surrounding arena, no boundary to cross. The universe changes from within, which means that even the most dramatic future scenarios do not involve expansion into something else. They involve transformation of relationships, of distances, of connectivity. Whether the universe thins, rips, stabilizes, or reverses, it does so without encountering an outside. The question of into never reappears. It remains irrelevant. This realization brings a quiet clarity. The universe is not incomplete because it lacks an outside. It is complete because it does not need one. All possible futures unfold internally. All changes occur within. And whatever the universe becomes, it becomes without reference to anything beyond itself. This does not make the universe simple. It makes it self-contained, which is perhaps the most unsettling conclusion of all. Once the fate of expansion is framed as uncertain rather than inevitable, the question turns inward, not toward the universe, but toward observers. Because expansion does not affect all parts of the universe equally, it reshapes perspective. What the universe is depends on where and when you exist within it. From our position, the universe appears vast, structured, and active. Galaxies fill the sky. Stars form and die. Light carries information across billions of years. But this view is temporary. It is a consequence of living during a specific cosmic era. Earlier observers, if such a concept had meaning, would have seen a denser universe. Later observers will see a quieter one. This means the universe does not present a single, stable face. It changes its appearance over time, and expansion is responsible. As expansion progresses, fewer regions remain observable. Distant galaxies slip beyond the horizon. Cosmic background radiation fades. Signals weaken. Eventually, the universe becomes locally isolated. An observer in the far future may see only their own galaxy, perhaps a few nearby companions, nothing more. From that vantage point, the universe would appear small, static, self-contained. There would be no obvious evidence of expansion, no visible relics of a hotter, denser past, no clues pointing beyond the local region. Cosmology, as we know it, would be impossible. This is not speculation. It follows directly from the mathematics of expansion. Expansion does not just separate matter. It erases evidence. It removes access to information, which means that understanding the universe is time-sensitive. There is a window during which certain truths are accessible. Outside that window, those truths are gone, not because they are false, but because they are unreachable. This introduces a deeply unsettling idea. The universe does not guarantee that its structure can be understood. Understanding is conditional. It depends on timing, and we exist at a time when understanding is still possible, but not forever. This raises a difficult question. Does the universe care that it is being observed? The answer from physics is no. The universe expands regardless of observers, regardless of comprehension, regardless of meaning. Expansion is indifferent, and that indifference shapes everything that follows. As the universe expands, it does not preserve access to its own history. It does not protect knowledge. It does not maintain transparency. It simply evolves. This indifference can feel hostile, but it is not. It is neutral, and neutrality is more unsettling than hostility because it removes intent. There is no goal, no narrative arc, no preference for being known. The universe does not expand for anything. It expands because its geometry allows it, and observers exist temporarily within that process. This realization forces a reconsideration of significance. If the universe does not care whether it is observed, then meaning does not come from cosmic acknowledgement. It comes from local experience, from structure that exists briefly, from systems that arise and interact before being stretched apart. This does not diminish meaning. It relocates it. Meaning becomes contextual, temporal, emergent, not guaranteed by the universe's overall trajectory. Expansion ensures that meaning is fleeting, not because the universe is cruel, but because it is unconcerned. This unconcern extends to boundaries. The universe does not define edges. It does not mark beginnings and ends in ways that satisfy intuition. It simply changes. Observers interpret those changes. And interpretation is where questions like, "What is it expanding into?" arise. The question reflects a desire for perspective, for a place to stand outside the process and observe it as a whole. But no such place exists, which means observers are always embedded, always inside, always limited. This embeddedness is unavoidable. Even the most abstract cosmological models are constructed from within the universe they describe. There is no external calibration, no absolute frame. This makes cosmology a strange science. It studies the totality without access to anything beyond. It asks questions whose answers must be internal, and expansion is the clearest example of this constraint. We cannot step outside the universe to see what lies beyond it, because stepping outside is meaningless. There is no outside to step into, which means that observers are confined to internal descriptions. Descriptions that evolve as expansion reshapes what can be seen. This internality is not a flaw. It is a defining feature, and it forces humility. We often imagine that with enough data, enough time, enough ingenuity, all questions can be answered. Expansion suggests otherwise. Some questions become unanswerable as the universe revolves, not because they are wrong, but because the information required to answer them is lost. This is not failure, it is structure. The universe is not designed to preserve its own intelligibility. It simply exists, which leads to a final personal implication. Our questions about expansion are not just about cosmology. They are about limits, about what can be known, about how long understanding can persist. The universe does not expand into something else. It expands away from states where everything was close and knowable, towards states where everything is distant and isolated. This is not a judgment, it is a trajectory. And within that trajectory, observers exist briefly, long enough to ask questions, long enough to glimpse structure, not long enough to see the whole. This realization reframes curiosity. We are not asking questions because the universe invites them. We are asking questions because we happen to exist at a moment when asking is possible. Expansion does not guarantee that this moment persists, which means that curiosity itself is time-bound, a temporary feature of cosmic history. This does not make it trivial, it makes it rare, and rarity changes how we value it. The universe may not care that it is being observed, but observation happens anyway, and that fact alone gives it significance. Not cosmic significance, human significance, the kind that does not require the universe's permission. Expansion may render most of reality unreachable, but it does not erase the fact that for a time, reality is accessible, and during that time, questions matter. Even questions that cannot be fully answered, perhaps especially those, because they mark the boundary between what can be known and what cannot. The question, what is the universe expanding into, sits exactly on that boundary. It persists because it exposes the limits of perspective, and those limits define us. At this point, the question has traveled far from where it began. What started as a curiosity about space has become a confrontation with limits. Limits of perspective, limits of connection, limits of meaning imposed by expansion itself. The universe does not answer our questions by resolving them. It answers them by revealing the conditions under which questions make sense, and expansion draws those conditions sharply. The idea that the universe is expanding into something else persists because it feels like a missing piece, a blank space beyond the frame. But what expansion shows us is that the frame itself is not fixed. It stretches, it evolves, and in doing so, It removes the need for anything beyond it. This realization brings together the themes we have traced: expansion as geometry, expansion as isolation, expansion as a filter on knowledge, expansion as a limit on observers. All of them point to the same conclusion. The universe is not incomplete because it lacks an outside. It is complete because it does not require one. Every attempt to imagine an external arena ultimately smuggles in assumptions drawn from smaller systems: containers, boundary, background. These concepts work for rooms, planets, and galaxies. They fail for totality. The universe is not an object among objects. It is the condition under which objects exist, and conditions do not exist in something else. They exist as frameworks. This is why expansion resists visualization. We are trying to picture a change in the framework using images that assume a fixed frame. The mind looks for a place where expansion is happening toward, but there is no toward, only between, only relative change, only evolving distance. And this difference matters deeply, because it means the universe is not moving forward in space. It is moving forward in time. Expansion is not directional. It is historical. The universe does not expand outward. It expands away from earlier states. This reframing dissolves the original paradox. We are not missing an outside. We are misplacing time. Once time is recognized as the axis of expansion, the question shifts. Not, what is it expanding into, but what is it becoming? And that question has an answer. The universe is becoming larger, colder, and more isolated, not because it aims to, but because its internal rules permit it. And that permission is enough. This does not imply inevitability in detail. As we have seen, the future remains uncertain. Dark energy may change. Expansion may alter course. But regardless of the outcome, one fact remains. All change happens internally. That the universe never crosses a boundary into something else. It only transforms its own structure. This has consequences for how we think about origins as well. If the universe does not expand into anything, then it also did not emerge from anything in the ordinary sense. The Big Bang was not an eruption into emptiness. It was the earliest state of the universe's internal geometry. This symmetry is important. There is no outside at the beginning, and no outside at the end. The universe is self-contained across its entire history. This does not eliminate mystery, it concentrates it. All mystery lies within, and that is both unsettling and clarifying. It means we do not need to search beyond reality for explanations. But it also means that some explanations may never arrive, not because they are hidden somewhere else, but because the universe does not encode them in a way accessible from the inside. This returns us to the role of observers one final time. Observers exist within a universe that is expanding away from its own past. They occupy a brief interval when structure, connection, and curiosity overlap, before expansion thins the universe too much, after the universe cools enough to allow complexity. This overlap is not guaranteed. It is a coincidence of conditions, and expansion defines its boundaries. This makes the present moment cosmologically significant, not because it is special in an absolute sense, but because it is positioned at a crossroads, late enough for structure, early enough for visibility. This is not anthropocentric. It is structural, and it reinforces the idea that questions themselves are products of expansion. Had the universe expanded faster, observers may never have existed. Had it expanded slower, collapse may have occurred. The universe we observe is one of many possible internal histories. Expansion selects among them, which brings us to a quiet resolution. The question, what is the universe expanding into, persists because it feels like a question about space. But it is actually a question about completeness, about whether reality is self-sufficient, about whether explanation requires something beyond. Cosmology's answer, however unsettling, is consistent. The universe is sufficient unto itself, not in the sense of being fully understood, but in the sense of not requiring an external context. It does not need an outside to change. It does not need a container to grow. It does not need a destination to evolve. It only needs time. And time, like space, is part of the same unfolding. This realization does not end inquiry. It redirects it. Instead of searching for what lies beyond the universe, we search for deeper structure within it. Instead of imagining edges, we study horizons. Instead of seeking external causes, we investigate internal rules. Expansion is not an invitation to look outward. It is an invitation to look inward, to understand how totality behaves when there is nothing else to reference. This is why the question endures, not because it has an answer waiting beyond the universe, but because it marks the boundary of how far ordinary thinking can go. Beyond that boundary, only abstraction remains, and abstraction is uncomfortable. But it is also where the deepest insights live. With this, Section 3 comes to a close. We have traced expansion from mechanics to consequence, from geometry to destiny, from space to observers, all without ever finding an outside. What remains is the final step. To step back one last time and ask what all of this means, not for the universe, but for us. That is where the story ends. By the time we reach this point, the question has changed beyond recognition. It no longer asks about space. It asks about expectation. When we first wonder what the universe is expanding into, we assume that expansion must resemble every other expansion we know. We imagine growth as outward motion. We imagine change as relocation. We imagine existence as something that sits inside something else. These assumptions feel natural. They are reinforced by every scale we experience. But the universe does not operate at those scales. And once that difference is acknowledged, the question begins to dissolve, not because it has been answered, but because it no longer applies. The universe is not expanding into anything, not because there is something hidden beyond it, but because there is nothing beyond it, in the sense the question requires. This is not a failure of imagination. It is a failure of analogy. We have been trying to understand a totality using concepts built for parts, and totality resists that translation. This resistance is uncomfortable. It leaves us without imagery, without metaphors that fully work, without a place to stand outside the universe and look back. But that discomfort is instructive. It tells us where intuition ends and where abstraction begins. Modern cosmology does not describe the universe as an object moving through a larger arena. It describes a self-contained system whose internal relationships evolve over time. Space stretches, distances grow, horizons sharpen, all without reference to anything external. This does not make the universe smaller. It makes it harder to picture, and difficulty is not evidence of error. It is evidence of scale. The universe is not required to align with human intuition. Human intuition evolved to navigate a narrow slice of reality. It was never meant to comprehend totality, which means confusion is not a sign of misunderstanding. It is a sign that understanding has reached its natural boundary. This boundary does not block inquiry. It redirects it. Instead of asking where the universe is going, we ask how it changes. Instead of looking for an outside, we examine internal structure. Instead of imagining destinations, we trace trajectories. Expansion becomes a description of evolution, not migration. The universe does not go anywhere. It becomes something else. And that shift from location to transformation is the key. Once expansion is understood as internal evolution, the demand for an outside evaporates. We no longer need a container. We no longer need a background. We no longer need a destination. The universe expands because its geometry allows it, and it does so without ever crossing a boundary. This realization has a quiet consequence. It means the universe is not incomplete. It is not missing a surrounding context. It does not exist inside something larger. It is not awaiting a reveal beyond its edge. It is already the whole story, not the whole explanation, but the whole domain. Everything that exists within it, and that includes the laws that govern its expansion. This self-containment is unsettling because it denies escalation. There is no larger stage, no next layer waiting beyond cosmology, no external reference that explains everything else. All explanations must be internal. This does not end inquiry, it intensifies it, because it means that understanding reality requires understanding it from within, without escape, without appeal to something beyond. This is why cosmology feels existential. It is not just about distant galaxies. It is about the limits of explanation itself. When we ask what the universe is expanding into, we are really asking whether reality has an outside, whether explanation ultimately points beyond itself. Cosmology's answer, so far, is no. The universe appears sufficient, not in the sense of being fully understood, but in the sense of not requiring an external context to exist or evolve. This sufficiency is not comforting. It leaves us alone with reality. There is no higher frame to step into, no external vantage point to simplify things, only internal relationship, only evolving structure, only time. And time itself is part of the system. This means the universe does not unfold toward an external goal. It unfolds according to internal consistency. Rules interact, conditions change, outcomes emerge. No direction is preferred, no destination is selected. Expansion happens not because the universe wants to grow, but because growth is allowed. This reframing strips expansion of intention. It becomes neither purposeful nor accidental. It simply is. And that neutrality is difficult to accept. We prefer narratives, beginnings that lead to ends, journeys that arrive somewhere. But the universe offers a different pattern. It changes without aiming. It evolves without destination. It expands without moving into anything. This does not make the universe meaningless. It makes meaning local, temporary, emergent. Meaning arises within structures that exist briefly against the backdrop of expansion. Stars shine. Observers ask questions. Then expansion carries those conditions apart. This is not tragedy. It is structure. The universe does not preserve moments. It does not archive significance. It allows it to arise and fade, and expansion governs the pace. This brings us back to the original discomfort. We want to know what lies beyond the universe because we want continuity. We want something stable behind change, something unmoving behind motion. But the universe offers none. Change does not occur against a fixed background. Change is the background. Space stretches. Time flows. Structure forms and dissolves. There is no deeper stillness beneath it all, only process. Once this is accepted, the question, what is it expanding into, becomes unnecessary. There is no into. There is only evolution. And evolution does not require an outside. It requires only internal possibility. The universe has that, which is why it expands. There is a reason the idea of an edge feels comforting. An edge implies orientation. It implies that somewhere, somehow, the universe could be framed, that it could be placed inside a larger context where its behavior makes sense at a glance. An outside would give us perspective. It would let us imagine the universe as an object, something finite, bounded, and therefore understandable. But the absence of an outside removes that privilege. There is no external frame to step into, no distance from which the whole can be seen. We are not observers looking at the universe. We are processes occurring within it. This distinction matters more than it seems, because when we imagine an outside, we imagine escape from limitation. We imagine a place where contradictions dissolve, where questions resolve, where uncertainty collapses into clarity. But the universe does not provide that place. It does not offer a higher vantage point. It offers only internal consistency, and consistency without perspective can feel incomplete. This is why the universe expanding into nothing feels wrong, not because it is illogical, but because it denies the possibility of a final reference. There is no absolute background, no cosmic wall, no external silence waiting beyond the last galaxy, only more universe, or more precisely, more internal distance. This realization strips away a subtle assumption that vastness requires room, that immensity must be measured against something larger. But the universe demonstrates otherwise. Vastness does not come from contrast. It comes from scale. The universe does not need an outside to be enormous. It is enormous because relationships stretch, because distances grow, because time allows separation to accumulate. Immensity is internal, and that is deeply counterintuitive. We associate size with containment. A lake is large because it occupies a region. A desert is vast because it extends across land. But the universe does not occupy a region. It defines region, which means its size cannot be compared to anything else. It has no neighbor, no surroundings, no external emptiness to push against. It grows by redefining how far things are from one another, and that growth has no upper bound. This is why asking what lies beyond the universe feels so natural. We want to compare, we want to contrast, we want to anchor immensity to something familiar. But the universe offers no anchor. It is the reference frame. This does not make the universe abstract in a dismissive sense. It makes it absolute. Not absolute as in unchanging, absolute as in complete. There is nothing missing from the picture, nothing waiting just beyond the edge, no hidden container, no larger emptiness holding everything else, only the universe, changing internally. This idea is unsettling because it removes a layer of explanation we instinctively reach for. When something grows, we ask where it is growing into. When something moves, we ask where it is going. When something changes, we ask what it is changing relative to. The universe answers none of these in the way we expect. It grows without a destination. It changes without a background. It evolves without reference. This does not violate logic. It violates metaphor. Our metaphors are built from finite systems. They assume boundaries. They assume containment. They assume context. The universe breaks all three, and that is why no analogy fully works. Balloons fail. Surfaces fail. Explosions fail. They all smuggle in and outside. The universe does not, which means the discomfort we feel is not a sign of confusion. It is a sign that we are pressing against the limits of representability. Some things can be described, but not pictured. Expansion is one of them. The universe expanding into nothing is not an answer that satisfies intuition, but it is an answer that preserves coherence. And coherence matters more than comfort, because comfort often depends on simplification, and simplification fails at this scale. This is why cosmology increasingly relies on abstraction, on mathematics, on relationships rather than images, not because physicists enjoy obscurity, but because reality demands it. The universe cannot be reduced to a picture that fits inside the mind. It must be approached through structure, through rules, through internal consistency. And those rules say the same thing again and again. There is no outside, not because it is hidden, but because it is unnecessary. The universe does not require an external arena to exist or expand. It is not expanding into something. It is expanding as itself. This realization subtly reframes how we think about limits. We often imagine limits as boundaries we can approach, walls, edges, ends. But the universe's limits are not spatial. They are conceptual. They define what kinds of questions make sense and what kinds do not. What is beyond the universe may be one of the latter. Not because the universe is infinite, not because it is finite, but because beyond assumes a framework that does not apply. This is not a rejection of curiosity. It is a refinement of it. Curiosity does not disappear when a question dissolves. It redirects. Instead of searching for what lies beyond, we ask how internal structure evolves. Instead of imagining edges, we study horizons. Instead of looking outward, we look deeper. And this shift is productive because it aligns inquiry with reality's actual structure. The universe is not hiding something beyond itself. It is revealing something about itself. That totality does not need context. That scale does not require containment. That expansion does not imply destination. These insights are not dramatic. They are quiet. They do not come with spectacle. They come with acceptance. And acceptance is often the hardest part of understanding, because it requires letting go of expectations rather than replacing them with new ones. The universe does not expand into anything, and that is not a mystery waiting to be solved. It is a fact waiting to be absorbed. The discomfort this answer creates is not accidental. It comes from a collision between scale and expectation. Human thought evolved to navigate environments with edges. Rooms end, horizons stop, journeys arrive somewhere. We understand the world by locating ourselves within it. We ask where we are, where things begin, where they end. These questions work locally. They fail globally. The universe, as revealed by expansion, does not provide the landmarks our minds rely on. There is no edge to orient against, no outside to compare with inside, no background to stabilize motion. And without those references, thought loses its footing. This is why the question keeps returning. If nothing lies beyond the universe, what is it expanding into? It feels like a refusal to accept disorientation, a demand that reality conform to familiar structure. But reality does not negotiate, it simply is. And what it is, at the largest scale, does not resemble anything we have encountered before. The universe is not a thing placed somewhere. It is the condition that makes somewhere meaningful. This inversion is subtle, but once seen, it cannot be unseen. It changes how we interpret, not just expansion, but existence itself. We often imagine that reality must be framed, that it must sit inside a larger context to make sense. But the universe shows that context can be internal, self-referential, complete without being enclosed. This does not imply that the universe is simple. It implies that it is foundational, and foundational systems do not sit inside other systems. They define them. This realization removes a comforting illusion, the illusion that there is always another layer, another perspective, another explanation waiting just beyond reach. Sometimes there is not. Sometimes what we see is the deepest layer available, not because inquiry has failed, but because inquiry has arrived at the structure that cannot be reduced further. Expansion appears to be one such structure, not reducible to motion through space, not explainable by external reference, only describable in terms of internal change. This makes the universe feel exposed. There is no protective shell around it, no enclosing darkness, no hidden frame, just reality unfolding, and we are inside that unfolding. Not observers standing apart, participants carried along by the same expansion we are trying to understand. This has a quiet implication. We are not watching the universe expand. We are expanding with it. Every atom, every distance, every moment of time. We are part of the process we are describing, which means that the question, what is it expanding into, includes us. We are not separate from the expansion. We are expressions of it. This is unsettling because it dissolves distance. We want to study reality as something external, something we can hold at arm's length. But expansion refuses that separation. It reminds us that there is no outside perspective, no cosmic balcony, no place to step back and see the whole. Even our most abstract models are built from within. This does not invalidate them. It contextualizes them. They are internal descriptions of an internal process, and that is all that is possible. This recognition forces humility, not intellectual humility, existential humility, the recognition that some features of reality do not bend to comprehension, not because they are hidden, but because they are too fundamental. The universe expanding into nothing is not an incomplete explanation. It is a complete one that resists visualization. And resistance often feels like absence. We mistake difficulty for lack, but here, difficulty is the signal. It tells us that we have reached a place where familiar categories stop working, where metaphors fail, where language strains. This is not the end of understanding. It is a transition to a different kind of understanding, one that accepts abstraction, one that accepts internal reference, one that accepts that some questions dissolve rather than resolve. This does not make curiosity pointless. It makes it more precise. We learn not just what to ask, but how to ask. We learn which intuitions to trust and which to release. The universe expanding into nothing is a lesson in that release. A reminder that not every where question has a location, that not every into question has a container, that not every mystery hides an object. Some mysteries hide assumptions, and once those assumptions are seen, the mystery changes shape. It does not vanish, it deepens. The absence of an outside does not make the universe smaller. It makes it more self-sufficient, more autonomous, more indifferent to our need for orientation. And indifference is often harder to face than hostility, because hostility at least acknowledges us. Indifference simply continue, the universe expand. Whether we understand it or not, whether we observe it or not, whether we find comfort in it or not. This is not a judgment, it is a fact, and facts do not adapt to expectation. We must adapt to them. This adaptation is not resignation, it is alignment, aligning thought with structure, aligning curiosity with reality, accepting that the universe does not owe us an outside, and that its absence is not a gap. It is a feature, one that defines the universe as complete, not finished, not static, but whole. In the end, the universe does not answer the question we started with. It reframes it. There is nothing beyond the universe for it to expand into, not because something is missing, but because nothing is required. Expansion does not point outward, it points forward. The universe grows by changing its own internal relationships, by stretching distance, by reshaping connection, by moving away from earlier versions of itself. This is not motion through space, it is evolution of space. And evolution does not need a destination, it needs only possibility. The idea of an outside feels natural because it promises orientation, a place where everything could be seen at once, a frame that would make the universe manageable. But such a place does not exist, and that absence is not a flaw in reality. It is a reminder of its scale. The universe is not something contained, it is what containment means. There is no surrounding emptiness, no cosmic background, no final edge where expansion stops and something else begins. Only more distance, more time, more internal change. This realization does not close the story, it quiets it. It replaces urgency with perspective. The universe does not expand toward an answer. It expands according to its nature, and that nature does not include an outside. We are left then, not with resolution, but with alignment, an understanding that some questions do not end in objects or locations. They end in acceptance. Acceptance that reality is larger than intuition, that structure does not require context, that vastness does not need contrast. The universe is not expanding into nothing. It is expanding without reference, and that may be the most honest description possible, because in the largest sense, there is nothing else for it to refer to, no elsewhere, no beyond, only the universe unfolding, and us, briefly aware inside it.